Hello students, let us start a new chapter, that is chapter number 3rd in your science textbook. Let us start this chapter, that is atoms and molecules. Are you familiar with the word atoms? The journey of atom begins much and before, that is nearly 500 BC. An Indian philosopher, Maharshi Kannan, postulated that if we go on dividing the matter, that is any substance which we go on dividing, we get smaller and smaller particle. Ultimately, a stage reaches where we know come across the smallest particle which cannot be further divided. He named this particle as Parmanu. Later on, the name word comes here, that is atom. And another scientist called as Antoine Lavoisier laid the given two important laws of chemical combination. These laws are law of conservation of mass. Mass is neither created nor destroyed in an ordinary chemical and physical changes. That means you cannot create a mass, even you cannot destroy a mass. Whatever the chemical and physical process are taking place, the mass will not be created and it can never be destroyed. Let us discuss with an example. A plus B give rise to C plus D. Here, let a process is taking place, a chemical reaction is taking place in which A is combining with B, give rise to C and D. Let we have taken the amount of A, that is the mass of A, 30 kgs, and the amount of B, that is 1 kg. But here we get a product that is C and D. And the mass of C that is obtained during this process is 28 kg and the mass of D obtained is 3 kg. When you make the sum of A and B, you will get 31 kgs. And when you make the sum of C and D, you will get 31 kgs. That means during this process, we can say that the mass, whatever mass we have taken before the process, is equal to the mass we got after the process. That means in this process, the mass is neither created, even the mass is not destroyed. That means the word we are using here, conservation of mass. Conservation means that is remains constant, or we can say conservation means the unchanged. That means whatever the mass is previous before the process is equal to the mass after the process. And another example, that is burning of wood. Maybe you're not going to believe this. We burn a log of wood, we get ash and smoke. So you may be thinking that that is a process in which we are destroying the mass, because we are taking a huge mass of log of wood and we are getting a few mass of ash. But here also the law of conservation of mass is applicable. But you may not be going to believe this. But here also the mass whatever we have taken, that is the log of wood, is actually that mass is conserved here. That is conserved, it is equal to the mass of ash plus smoke, because ash consists of some of the substance, its mass, and the smoke also consists of the substance, molecules, atoms, all these, when you make the sum, you will be getting the mass equal. So here also the law of mass of conservation is applicable. So if you weigh the mass of the substance before the reaction and mass of the substance after the reaction, here you get the mass will be equal to same. That means whatever the reactants are there, that means the substance which is before the reaction, their mass, and the substance after the reaction, their mass will be get equal. Thus, we can say that law of mass of conservation, that means law of conservation of mass. It states that mass can neither be created nor be destroyed in a chemical reaction. So all of you have to note it down, this law, that is law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction. A scientist called as Lavoisier, along with some other scientists, noted that the compound is made of two or more elements, and all these elements combine in a fixed ratio. Thus, it gives rise to another law that is called as law of constant proportion or law of definite proportion. Was proposed by Proust. What is actually this definite proportion? Definite proportion means fixed ratio. Let us take one example of law of definite proportion. Water. You are familiar with the word water. Water, chemically it is made up of hydrogen and oxygen. Here H is the symbol for hydrogen. That means it have two hydrogen and one oxygen atom. So in water, which is a compound made up of two type of element, that is hydrogen and oxygen. If you are familiar with the formula for water, that is H2O. We always write water as H2O. You have ever seen the water writing in this form H3O? No. Water is always written as H2O. Why it is written always H2O? Why we can't write water in another way? Because in water, hydrogen and oxygen are combined in a fixed ratio. That is, oxygen is to hydrogen ratio is 8:1 ratio by mass. That means when 9 gram of water is decomposed, it gives rise to 8 gram of oxygen and 1 gram of hydrogen. So, whatever the source of water is there, in all these cases we can find that oxygen and hydrogen are arranged in the same ratio, that is definite ratio. Similarly, whatever other examples are there, in all examples we can find that atoms are combined in a definite ratio. So we can state that law of constant proportion, it states that in a chemical substance, the elements are always present in a definite proportion by mass, which is given by Proust. Later on, John Dalton provided the basic theory about the nature of matter. As shown here, he is a John Dalton. He is an English school teacher and a chemist. He took the name atoms, which means undivisible by the Greeks, on the basis of the idea of undivisible particles given by the Indian philosophers and other philosophers. He has took the name atom for the smallest particles, and he given a theory based on the law of chemical combination. That theory is called Dalton's atomic theory. Dalton's atomic theory, which is given by John Dalton. According to the Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates of his theory may be stated as follow. That is, first postulate: all matter is made of very tiny particles called atoms, which participate in the chemical reaction. That is the first postulate. It means that whatever matter is there, matter means which have mass and occupy space. Let's take the example of book is a matter, air is a matter which made up of gases. So whatever substance around yourself is a matter. So all the matter are made up of tiniest particles, which is called as the smallest particle, that is called as atoms. And these atoms are participating in the chemical reactions. Second point: atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. As we have discussed about the mass of conservation, that means law of conservation of mass. In this we have discussed that we can't create a mass and even we cannot destroy a mass. Similarly, the atoms cannot be created and even the atoms cannot be destroyed in a chemical reaction. That means the atoms are conserved. So this statement belongs to the statement of law of conservation of mass. Next point: atoms of given element are identical in mass and chemical properties. That means if we take atoms of same element like hydrogen, so whatever hydrogen atoms are there, all atoms are identical in mass and even in the chemical properties. But when you take the atoms of different element, that is in the fourth point, atoms of different element have different mass and chemical properties. If you take atoms of different element, like you take case of hydrogen and oxygen are the two different element, the atom of hydrogen and atom of oxygen is always different. That is different in mass and they are different in chemical properties. So the fourth point states that atoms of different element have different masses and chemical properties. Next point: atoms combines in the ratio of small whole number to form compounds. Here, atoms are combining always in a fixed ratio, that is a small whole number ratio. It gives rise to compounds. Just now we have discussed about the case of water. The water is combined in the ratio 1:8 ratio. So here they are combining in a fixed ratio, that is in the small whole number ratio to form water. So this point, that is the fifth point, relates to law of definite proportion. The next point, that is relative number and kind of atoms are constant in a given compound. That means in a compound like water, the number of atoms are fixed. Like the case of water H2O, that means 2 hydrogen and 1 oxygen, that is always fixed. That is constant for a given compound. And the kind of atom are also constant. That means, as we have discussed, water is always made up of hydrogen and oxygen. We can't imagine the water with the other element. It is always made up of two elements, that is hydrogen and oxygen. So the last point states that always a compound made of particular type of atom, that is fixed atom, and in a fixed number. So are the postulates given in the John Dalton's atomic theory. So let us summarize this video. In this video we have introduced on atom, that means how the different Indian and Greek philosopher come to the word of atom. Then we have discussed about law of chemical combination, like law of conservation of mass, which states that mass can neither be created nor be destroyed. Next, law of constant proportion, which states that always the atoms in a compound is in fixed ratio. And Dalton's atomic theory, in this we have discussed about the different postulates given by John Dalton, and he has used the law of conservation of mass and law of constant proportion in his theory. So in the next video, we'll be going to discuss atoms and molecules in detail. Thank you everyone.